Hey everyone, this week on Paul's Security Weekly, we will do an interview. A technical segment is what we're going to lead in with first from Mike Roderick and Adam Gordon of ITProTV. We'll be talking about virtualization and the trusted platform TPM and how to use virtual smart cards and things of that nature, which is awesome. It's actually Mike and Adam's first time on the show. Mike's actually been here in studio. I believe he was here for episode 500. So
I was there for the 500 blizzard.
Yeah, you were there for the blizzard. So now we had to get you having on the show, which is great. And then we will talk about security news. The order's a little out of whack this week. So in the security news, we are going to talk about blaming Russia. Oracle and Microsoft released some patches, hacking cache converters, Apple's Face ID, which you knew was going to come up, horrible bug bounties and NDAs with a drone company, and books I'd give to my 30-year-old self. I thought this was a great blog post that I wanted to touch. Not so much security related, but interesting nonetheless. And 121 pieces of malware flagged on an NSA employee's home computer. I thought that would be an interesting topic to discuss as well. Then we have a pre-recorded interview with Kyle Wilhoit from Domain Tools. And let me tell you, you definitely want to stick around for this interview. It was absolutely fascinating, a look into the creepy underground and underground forums and the dark web and the deep web, as it were. Very, very interesting. Kyle, I actually pushed him a number of times until he cried uncle and said, no, I can't tell you how I track those people and how we trick those people into getting caught because I don't want them to know. So stay tuned for all that and more on this episode of Paul's Security Weekly.
This is Security Weekly, for security professionals, by security professionals. Broadcasting live from G-Unit Studios in Rhode Island, it's the show where exploits run wild, packets aren't the only things getting sniffed, and the cocktails flow steady. It's Paul's Security Weekly.
I'm, of course, your host, Paul Asadorian, excited to be here, as always, on Paul's Security Weekly.
Hi, and welcome to the show. I totally introduce our host right now, but I've got a totally awkward boner.
What? Where? Oh, hey! I'm in the studio with you guys. That's kind of cool.
Sounds like a plan.
And we'll at least have one person listening.
That's right. Just saying.
Yeah, I know, and I appreciate it, and I'm glad you enjoyed your spooning with Jeff. But you know,
Hey, that's
Actually built a new office.
Oh, okay.
Yeah, third baby on the way, so I needed a new office.
Nice.
I lost my old office. That's now the baby room.
Brought to you by... Has your network been breached? Cybereason can help you answer this question. Cybereason products hunt for threats within your network and eliminate them in real time. To Cybereason, real time means within seconds. Founded by former military hackers who don't play by the rules, they've built this experience into their platform. Harness ingenuity and imagination, not just code, to defeat attackers. Cybereason, disrupt the adversary and let the hunt begin. Endgame automates the hunt for both known and never-before-seen adversaries in enterprise networks. Built on unique knowledge on the adversary's tools, techniques, and tactics, Endgame's centrally managed agent prevents, detects, and responds to advanced adversaries in the earliest stages of the kill chain without prior knowledge. Endgame, automate the hunt. The average time between being hacked and realizing you've been hacked is 1 year. Can you afford to let an intruder roam your network for that long? Can your company weather the fallout when this comes to light? Black Hills Information Security can find the bad guys in your network and train you to do it yourself. Email consulting@blackhillsinfosec.com to find out how a hunt teaming engagement can help you find a persistent threat in your network.
Like a bag of rabid cats tossed into a VW Beetle after being dipped in bacon grease, it's Paul.
Yes, we are here. It is Paul's Security Weekly, episode number 537 for Thursday, November 16th, 2017. Couldn't be more excited that I, don't drive a Volkswagen Beetle filled with bacon grease and something else.
But you wish you did.
Whatever, maybe not, but It's okay. I want to welcome all of our viewers and listeners today and introduce our in-studio host for this evening, who made it here after spending an hour and 38 minutes in traffic, Mr. Doug White.
I did make it here, and the traffic was fun, and I got to think about all kinds of horrific things while I was there, like cats dipped in bacon grease, which is just the kind of stuff you think about. It was rabid cats dipped in bacon grease. Yeah, I was like, I would rather be with rabid cats dipped in bacon grease than in this traffic.
I was paging Dr. White, Dr. White to operating room 1. Dr. White, doctor.
The patient is going down for the last time.
That patient would have been long gone if it took an hour and 38 minutes.
The way the real world works. I'm sorry, man, but I would have been here sooner.
We have to get your own private helicopter to come in.
That's what I was thinking. A drone.
A drone?
Just like a little mini drone that just attaches to you, and you just like hang there like this, sort of being. I was thinking sort of like this, and there's all these people just sort of going overhead, like.
And then someone hacks your drone, and then you're screwed.
And then there's the people going like, and it's like, oh yeah, thanks. What a great day.
You have such a vivid imagination, Doug. I don't know why.
It's a mess in here.
It's a very interesting place to be.
Thanks, Kurt.
An interesting show when you're on. Speaking of people on the show, Mr. Jeff Mann joins us via Skype. Jeff, welcome to the program.
Hey, glad to be here. I have a quick question for Doug. What year VW Beetle bus?
I was thinking like 69, but that's the only year.
It was a good year. That was a good year.
That was a good year.
Good vintage Volkswagen. Jeff and I had some good vintage cigars and scotch when we were at Sands Hackfest. That was fun.
Jeff and I had cigars. Jeff and I had cigars and drinks at Wild West Hackenfest in
Funny
South
how that
Dakota.
works.
I know.
When Jeff's around, we have like drinks and cigars.
We got to talk to like really strange people from North Dakota who were trying to understand security while being really, really drunk.
Yeah. Nice.
And dressed up for Halloween.
That's right. They were dressed for Halloween as like Mario Kart characters or something. It was.
So would you have rather been in traffic or back at Wild West talking to those folks from North Dakota?
Oh, back at Wild West by far. That was a lot more fun than sitting in traffic in Providence and watching people try to text.
Now, Jeff, before we get started, I want to get your take on the Sands Hackfest. I don't know if you want to reserve that maybe for later in the show. You want to think about that? I want to do a little recap. I did some on Enterprise Security Weekly. Did you want to do that maybe later? I don't know how many talks you got to see while you were there.
I got to see a couple talks. I'd be happy to pipe in. Why don't we save that for the news segment? Or I can do it now. It's up to you.
No, it's good. We'll save it for the news segment, and we'll give a little teaser that Jeff and I, and it's a very interesting, for me, it was a very different take on a pen testing conference, which was both refreshing and awesome. So
cool.
Stay tuned for that. I have no teleprompter because I don't. It's not the it's the Bluetooth technology that. In any case, I will talk about ITPro.tv. You can go to ITPro.tv/Security Weekly, save 30% off your monthly subscription for the lifetime of your active subscription. You get a 7-day trial and 30% off using a discount code SW30. See, who needs a teleprompter?
You don't need a teleprompter for that.
Nailed it cold.
You should have been there already.
Anyway.
That's right. And we have with us some folks from ITProTV, which I'm very excited to have on the show and have a discussion with, primarily about virtualization and TPM. First up, we have Mike Roderick, and he's only first because that's the order you're in the show notes, not to play favorites. Mike is first. Mike found his niche little later in life after being from Norman, Oklahoma, in the raucous scene of the 90s country western bar scene. Interesting.
Oh, gosh, you're looking at the bio off our webpage.
I'm going to read your bio because it's interesting.
No.
It was there he developed the skill that would propel him to mullet fame, line dancing. It is here that ITPro.tv, his true skill shines. He's their resident security kung fu master, only equaled by his skill in flattering our fearless ITPro.tv leader. With 10 years of IT instruction experience, he was hired as an ITPro.tv edutainer in 2014. Mike enjoys working at ITProTV, which is what I'm told. That's what it says in your bio, Mike. Maybe you'll tell us different, because he helps others become successful in IT and technology. Mike, welcome to the program today.
Hey, thanks, Paul. And this is what you get when, they ask me to write a bio, and I tell them, nah, I'm not going to do that. They get somebody else to do it, and you have no idea what they're going to put in there.
Oh, they should have got me to do it.
But
yeah, it would be really interesting then.
We'd have rabbit cats and yeah.
And the Macarena.
Now, Adam Gordon, who is also an edutainer at ITProTV, is here, and it says, not too long ago, rock star legend Jimi Hendrix posed the important question, are you experienced? Foreshadowing the birth of one of the most expert Microsoft experts in the history of experts, Adam Gordon. Holding 160 certifications and counting, Adam's encyclopedia of knowledge is only rivaled by his massive and quite ridiculous collection of socks. Adam's 30-plus years as an IT instructor in the private and public sectors has fueled his passion for gobbling down espresso like a college kid downing beers at Oktoberfest. These are very enthralling bios. I'm just going to continue reading because this is so fun. His long hair and assortment of bracelets are a memento of his days working in the music industry, rubbing shoulders with celebrities in exclusive European clubs, but now lives in a quiet, married life in South Florida, teaching and traveling with his wife and 2 daughters. Adam has been a SME for ITProTV for some time, and they're excited to welcome him as a full-time host. And check out his 19-page resume when you have a couple hours to kill and want to feel like an underachiever. Learn all things Microsoft with Adam and stay updated on the latest trends in sock fashion, live and on demand with ITProTV. Adam, welcome to the program.
Thank you very much. This is what happens when you let us write each other's bios, actually. But it's a pleasure to be here.
The bar, and I see that it looks like you folks have crashed Don Pizzette's office.
We have. We took over.
Yeah, we did.
That's awesome.
I'm waiting to hit the bottles as soon as we cut the camera.
Yeah. And unfortunately, I know that they're empty because that's the first question I asked. I'm like, oh, party up here. And I'm like, they're all empty. Party already happened. So Adam and Mike, I want to ask you, start the discussion and talk about virtualization, specifically VMware. And where I wanted to start before we get into some of the TPM stuff that you have a demo of and everything, I wanted to talk about VDI because I get questions about VDI, and I'm not a VDI expert. In fact, I've never used VDI. I've only read the marketing brochures, so I'm not qualified to comment on VDI. But a lot of people are trying to tackle.
You are qualified to sell it, though.
Probably qualified to sell it. I can certainly spell it as well. And so, what people ask is, how does VDI help me in my security architecture? Can I use it to help solve this nasty endpoint security problem?
Great question.
Rock, paper, scissors? You want to?
The first thing I think of with implementing VDI and its help in security is the fact that we're really maintaining a single image. So as far as patch cycles go.
Yeah, take a step back. For those that aren't familiar with VDI, like what is VDI?
Sure. Virtual desktop infrastructure where we're basically spinning up a virtual desktop when an employee needs to log in. And so each employee that logs in is going to get a new copy of this machine, the virtual desktop that they're going to utilize. And depending on how we set up, there's many different ways we can set it up, where if they have individual machines that they get, or if it's a brand new copy of this virtual desktop every time they log on, no changes are saved to it, documents, things like that get saved outside of the VM. So it can really help with like patch management and things like that, because I'm maintaining that single image. I don't know what else you want to throw in there, Adam.
So certainly the single instance image in terms of patch management, definitely a big plus. But I think overall configuration management, change management, all things that go into that. But even more importantly, when we think about starting to do things like, hey, we have an issue where maybe we've had some sort of a breach or we have a problem, traditionally, it comes from, more often than not, people having the ability, the permission, and or the need to go into their machines and start messing around and doing things that perhaps central IT management capability is going to prevent, but because we have to give them the override to do it, they get in trouble, right? Mm-hmm. With VDI, we're standardizing that desktop environment, we're stabilizing an image, and we're locking it down so nobody's going to go in and make changes without permission. We're eliminating a lot of the unknown, the uncertainty. We're also standardizing the way people interact and collaborate. We're going to avoid a lot of the concerns that come from the unknowns. And when they do, in theory, go places they're supposed to not go, and we all know, right, that's going to happen, and maybe they download something or they get malware or whatever the case is, reverting that image and or dealing with it is a lot easier because we are sandboxed, number one. So we have the capability and the abilities to isolate very quickly. If we're using continuous monitoring capabilities, we hopefully flag that almost immediately. We can react quicker. And because we're not saving changes necessarily, creating differencing disks, essentially in cloned images, it's easier to manage that differential and deal with the concerns associated with it. So it's just good all the way around for lots and lots and lots of reasons.
Now, what I've heard is that VDI has a very difficult deployment and maintenance that's associated with it. While it solves a lot of problems, it's difficult to deploy. And so I guess along those lines, one of my recommendations I have for folks that are like, hey, I've got legacy applications that require legacy versions of the browser. I don't want to expose them to the internet, so I'll give them a VDI instance with a supported browser, and they can basically only get to the application, and they use it almost to deploy an application. Is that not the right way to do it, and how can we improve the maintenance and overhead that is experienced with deploying VDI?
So definitely one of the right ways to do it, no doubt about it. Great usage case in that respect. In terms of deploying the overhead, the requirements, the concerns, it's really a learning curve, right? It's like anything else. You got to skill up your team in order to understand how to deploy and support. You don't have this huge infrastructure investment potentially, depending on the scope of the usage case. If you're spinning up 5 or 10 or 20 limited instances in what you were describing, Paul, it's a fairly straightforward solution. 1 or 2 reasonably well provisioned hosts in terms of resources are pretty much what you're going to need, and bandwidth, because you obviously have to have the right amount of infrastructure bandwidth to be able to create the opportunity for those instances to be run. But other than that, we're not talking about a huge investment in time or energy. I think where people get sidetracked with VDI and where they go into the rabbit hole is around trying to do an enterprise-level deployment with existing infrastructure and architecture, and they don't step back and understand the specific things we need to address and be concerned about. High-end storage for requirements around spinning up those instances, and IOPS and latency around the storage platform become a bottleneck, so we got to worry about that. We need bandwidth in general, so we got to worry about that. And we need hosts, plural, that are going to be up to the task of creating and running these instances and essentially provisioning them out. And people think, oh, I've got 2 or 3 main, huge hosts that I run for cloud infrastructure on the server side to virtualize. I could probably do more or less the same thing with VDI. The requirements are smaller per instance, but because you're running so many of them, potentially in an enterprise scalable deployment, you got to really be on top of your planning and your thought process around capacity and scalability to understand how to scale up. And where most of my customers and clients have had problems is they don't plan, they plan well for the initial deployment. They don't plan for the scalability over time. And as they start onboarding and spinning up and growing laterally and horizontally in terms of their usage profile, they run into roadblocks because of the resource issues.
It's an interesting take on the problem, Adam, because what I often hear is that, well, VDI doesn't scale. But what you're telling me is you've planned poorly, and therefore your architecture has not allowed it to scale.
You need a plan to be successful, right? I mean, that's a general thought process in our industry for everything we do. And the problem is, unfortunately, more often than not, people aren't really understanding what planning to be successful means, or the guidance they're getting may not be as unfortunately, as spot on as it should be. And they plan to be marginally successful, perhaps even plan to fail, because they don't understand what planning to be successful really means.
That's true of all virtual machines. I mean, I don't care what it is, or whether.
And what we're talking about here is a mainframe with consoles.
Yeah, and
right?
it's true of the mainframe too. I mean, if you sit down and you originally bought the mainframe with the idea, and you went out and inspected, and IBM, you said we're going to have 50 users. And then 2 years later, you say we got 500 users. It's still not scalable. I mean, yeah, you can go plug more, rack or plug more CPUs into the thing, or you can plug more cards into the slot.
Or consoles, right? I'm thinking even in the old days when the users accessed it via a console.
It's really
system.
very similar to the way that the mainframe blew out shells, and because a shell was really just the same thing as these VDI type models, or multi-point server, or VMware has the same kind of thing. All these have this same sort of model, and it's no more scalable than the hardware you're running it on, so you can always say, okay, just throw another rack out there and we'll scale it on up. So it is scalable, but it's not scalable easily if you didn't plan ahead, because you're going, we need 10 times what we thought we did.
Right.
And that's budget.
And that's the downside. I mean, that right there is the exact issue. We traditionally will recommend to customers, hey, this is what you want to be doing today. Where do you want to be in the 30, 60, 90 thought process, right? Where are you in a year? Where are you in 18 months? Beyond that, maybe 24 months. You can't really assess and plan beyond that in a reasonable way, but you can add overhead and infrastructure and say, if we double every 6 to 12 months, what does that capacity look like? And let's leave enough overhead, or let's plan on adding overhead over time to be ahead of the curve. And that's where people often make the mistake, and they don't really scale.
That and the sales people jump on that and undersell it too. At least that's what I've seen. Is they come in and when you say, well, they say, where do you want to be in 5 years? And you go, wow, we'll have 5,000 users and we got 50 now. Then the salespeople go, well, that's what this is going to cost. And they go, but you don't really need all that right now. You could back that down because we want to get the bid. So we've seen that a lot.
There's a pro and a con to that. I'm sorry, Paul, I didn't mean to cut you off. Just one point from the real world perspective, right? It's a great point you're making, but the upside is, we don't spend as much, right? So we defer the pain, and we get the liability as well as the benefit of buying newer technology along the way as we scale, which can be a good and a bad thing in terms of integration. The downside is if the baseline for planning is not really laid properly, you don't have enough infrastructure to not only run and ramp initially, but to scale for the first 12 months as you're growing. You run into a brick wall almost immediately. You're no longer maintaining. You're trying to play catch up while you're actually deploying, and you're never going to recover from that mistake. It's very difficult.
And I always tell people to take that graph and scale your hardware budget up right along with that, because you're going to get more bang for your buck out in the future. So just make sure that the hardware you're buying is scalable. Make sure you understand that you're going to have to pay more money as that thing scales up along with your users. And that way you actually get better and more hardware out in the future. Just be sure the stuff you're buying is scalable in that way. And I like that graph better than let's just buy a big hunk of metal right now and hope it holds up over the long run.
What's interesting is if we go back to the creating a VDI for users so they have a browser to access things. I've seen snippets of a talk from, I believe, someone that worked for Docker or some other container company that had basically containerized their browser. The fact they had to give a whole talk on it tells you that that's not quite easy to do. I've also talked with vendors that can create virtual browsing proxies, basically do the browsing on behalf of the user inside of a container. Mike and Adam, are you guys creating content around containers, and what are your thoughts on some of these newer methods that are able to provide the user with almost a sandbox environment for browsing?
Both of us can answer or speak to it. I'll just speak from my own content-driven experience in terms of where I am and what I'm doing. Mike and I are both working in the same general areas, but we do slightly different things based on our skill sets and focus. So we actually do have content on containers that's already spun up in the library. In Server 16, for instance, I just finished up a set of shows on the MCSE arc or trajectory around certification. On the security side, we did stuff on Docker, containers, and Nano on the Microsoft side. So we have it specific to one vendor. We also have some stuff from Justin, if I'm not mistaken, right? That's also done containers and Docker more broadly and generically.
Yeah, over on DevProTV, we've got some container content as well.
That's awesome.
So we're creating content. There's definitely stuff, and there's more stuff coming on the way that we're envisioning doing and or is already planned for launch in the next several weeks, months as we put new content together.
And one of the things that, and other security professionals tend to agree with me, that our knowledge and understanding of Docker inside the security community is extremely, I would say, going on a limb, not even going on a limb, I would say it's extremely low. And I wanted our listeners to know that you have some content on Docker and more to come, because like we talked about with VDI, making sure you plan your architecture, and there's a learning curve, as Adam said. There's a learning curve with learning Docker as well. I have to say, today was my first successful production deployment with Docker Compose. Yay! The crowd goes wild.
Yeah. Awesome.
I'm still skeptical. Like, I really don't think it actually worked, although everyone's telling me that it worked. So we'll go with that for now.
Soon we'll know the truth.
But I just, the fact that you folks are creating resources, I think, is important, and I want to let the security community know that they can go there and do that, because it's important as we talk about VMware, which to me represents some older technology, and they've had a struggle keeping up in the market because of cloud and because of containers. that you can get some of that newer technology as well.
And you should start watching some of this content before you jump into the dark, murky Docker waters that are out there waiting for you.
It's like I tell the interns, I'm like, just go try it, and when you get an error, Google search for it, and then go from there.
Well, yeah, that's fine to go try it, but it's like when you want to get serious about it, it's kind of like it's now you're not just snorting a line of heroin, you're getting ready to shoot, a serious.
And Doug, you couldn't be more right, and I'm sure virtualization and a lot of other technology are the same way. When a technology is new, what I've realized is that a lot of people are like, hey, here's how you spin up some new Docker containers. Right. You're like, that's great. And then you're like, well, how do I do this in production? And it's like, oh, wow, all those posts from all those thousands, maybe hundreds of people in Docker's case are completely useless to me.
Dev is fun. I mean, dev's a blast, and you're going to love it. And that's where you do just go dive right in and hope the water's deep enough that you don't get killed. But when you do go to prod, that when you get into production,
when I do it in production.
Well, Paul's the prod man. Paul's ready to prod anything at a moment's notice. But I mean, when you go into production, that's when life is going to change, and you're going to bring your enterprise crashing down, or you're going to run into these long-term scalability issues, long-term viability issues, because you didn't think it through, and you said, "Oh yeah, this was fun, and it worked when we were playing around in the lab, but now I've got 100,000 customers on this thing."
Or you're going to have your first successful deployment using Docker and Docker Compose, and you're going to say, well, there's a mistake. I need to push a new one out, and then less than 3 minutes later, there's another new release out.
Exactly. So
that's the culmination of 8 months of work that I've realized with Docker is that once you go through that learning curve, and Adam was talking about it before with VDI, to bring it back to virtualization, like once you experience that learning curve, now you're on the other side of it, right? Like there's definitely like not a bell curve, but there's a ramp up to it. Sorry, Adam.
One of the things, just throwing a quick thought on that. So, around Docker, with great technology, can't say enough good things about the concept and the ability to go into the future with new technology. It's always exciting, and there's ups and downs for everything, right? But we do have content, which is great. But the other thing we're doing around the content is not just spending time on Docker, but we're building content out around additional supporting technologies like Ansible and other automation and DevOps generically as a kind of catch-all category, right? All the automation and support technologies that you really need to make sense of Docker, whether it's Compose or one of the other platforms that will let you do those things. So we're really starting to build that base and give you not just the ability to understand, as you said, the core, but let's talk about how you really operationalize that technology so you can make it work, as opposed to just simply saying, hey, look, I was successful, but I can't really use those skills in production. I could just say that I'm able to do this, but it doesn't really mean much. We're trying to take that approach and really make it scalable.
Hey, here's my Docker file, and you can run, Nginx and UWSGI and MySQL all in the same container. And I'm like, yeah, dude, that's great. That works great as a test, but in production, as Adam is saying, to build on what Adam is saying,
totally impractical.
Right? Yeah, you've got Kubernetes, and you're deploying hundreds, if not thousands, of containers, and you're orchestrating them all together between potentially 3 or 4 different staging areas: development, and production, and QA. I always used to talk about the great database fallacy. Was that I got my database working, and you're so happy. But then when database is one of the most instantly scalable things on earth, because when you're fooling with it, it's really small. And the minute you turn it loose and 200,000 people log in, the database goes from like 0 to infinity in about 2 seconds. And you never thought about that, because when you were playing with it, even when you got 6 people of interns to sit down and enter records, it seemed pretty good. And all of a sudden, that not only blows up inside your Docker, but your Docker blows up and all your instances blow up. And all of a sudden, you have a real problem that you never really thought about. And that's a real quick one that happens early in prod. Yeah. So Adam and Mike, you wanted to talk about TPM. So describe the TPM model and how it applies to virtualization.
One of the things that I've been playing around with is the fact that we're now able to virtualize our TPM inside like VM Workstation, which is something that I've been waiting for. It's available in other virtualization technologies, but gives me the ability to kind of play around with it, test it, do demos with it, show it on some of our episodes, things like that.
So Mike, I'm sorry, just back up for our listeners. What is TPM, and why would I want to implement the model?
TPM, Trusted Platform Module. It can be implemented in several different ways. Typically, we see it in a physical machine. We're talking about a separate semiconductor, or separate chip on the motherboard where that's implemented. And the reason we like these is the segregation that we get, right? The TPM is where we're going to store some cryptographic keys for like BitLocker. It can store many things in there, but it's isolated certificates. We're going to take a look at. We'll even show you how we can do virtual certificates or virtual smart cards inside of TPM. But it's isolated. It's a trusted base, right? That's isolated from the operating system. So the keys, the cryptographic keys and things like that, stored outside the operating system where, hopefully the idea is inaccessible to somebody that's hacking into your OS.
So do you use
Think about
TPM?
essentially a...
Oh, sorry. My
Go ahead,
question.
I'm sorry.
My question was: do you use TPM to authenticate or validate the user, or the applications, or both?
Well, it's really storing the authentication information, right? The keys or the certificates are going to be loaded in there. And basically with a TPM and a virtual smart card, the way Windows sees it, for example, is that you've always got a smart card reader plugged in and you've always got your smart card loaded up.
Oh, I see. So it's kind of like a hardware vault built into your computer.
Yes, exactly.
Essentially a hardware-based crypto vault, right?
Okay.
So you're storing your cryptographic information.
I've always wanted to ask this question to somebody who knew. Is there a gap between that hardware vault and then the VM? Because I always was thinking about that, was maybe there's a gap between that plugged-in module and the actual VM that's like on the bus or somewhere that you could get to, or is all that stuff sent in some kind of really nice encrypted format?
That's a good question.
So it's a great question. So there's two answers to that. Both, I guess, would be yes, right? So interestingly, in the demo we're going to do, the Mike's going to drive for us here in a minute, we're going to see that we're implementing, or Mike will implement, a virtual TPM. So not a hardware-based one, but essentially a virtual instance. It can actually be done independent of the TPM being installed and configured in the operating system on the physical host. So in Hyper-V in Microsoft, in VMware, and in both, in ESXi and or in the workstation, we actually can implement the virtual TPM, attach it to quote unquote the virtual machine instance, the guest OS, as a piece of hardware we add in, and we initialize it and use it whether there's a physical TPM in the machine that's hosting. And as a result, essentially we run independent of the TPM on the host, because the virtual TPM becomes a self-contained virtual hardware instance as part of the VM. So there is a gap, if you will, right? Because we're not relying on the physical TPM in order to use the virtual TPM instance. And it is all encrypted as part of storage. And as a result of that, it's not accessible. So there's no way to get into it unless you essentially crack the virtual machine itself, which, as far as anybody's been able to prove up until now, everything being relative, right? Always a disclaimer. Current encryption standards being used, current computing power being thrown at it, has proven to be an unrealistic, unfeasible attempt. We're currently actually using, AES-NI on the encryption side for ESXi, for vSphere 6.5. So a high-level version of AES with 256-bit encryption. You're actually getting 2048-bit keys, which are seen as being strong enough to withstand anything we can currently throw at them.
Quantum computing aside, obviously.
Yeah.
Quantum computing aside, right? Of course.
I'll get into that.
No, we won't go there. Is the TPM is I understand it's almost like a key store. Is there how do you load the initial keys onto it? Like I'm thinking of there are like SCADA firewall providers that have like a hardware thing where basically, data can go in, but it can't leave. And there's like a physical hardware barrier where things can come in and out. Is the TPM kind of similar when it's actually physical hardware, not virtual?
So when it's physical on the host, let's say we're actually dealing with this cryptographic silicone chip that Mike was talking about, the module. And you may have seen HSMs, hardware security models, that are essentially external versions of TPMs, right? That's more or less what you're describing. So they work in a similar fashion. You're putting stuff into the system through an interface in the motherboard. It's essentially, although you do have limited capabilities, depending on the vendor and how they're implemented in the OS, for instance, in Microsoft in version TPM 1.2, in Windows 10 or these other OSs, we can go in and have some basic management GUI interface capabilities to reset the keys and essentially reset the TPM. But with version 2.0, the newer standard, we don't have any capability to essentially get in and see it and interact with it because it's totally isolated. So it really depends on the hardware vendor's implementation and the OS binding to it. But it is seen as essentially a solution that we can put stuff in, but you really can't go in and remove stuff unless you're using an approved interface in a channel. And that's only through the OS and is protected by the kernel. So there's really no way for us to get to it.
Can I ask one more question then? So one thing that always worries me about anything that's virtualized is that when you have a piece of hardware, it's a piece of hardware. I mean, it's a thing. And when you have something that's virtualized, even if it's virtualized hardware, it essentially is in memory.
It's in software.
It's in software. So, yeah, to slowly work my way around to the proper terminology. It's in software. But I guess my point is anything in software can effectively be corrupted by, whether it's a memory leak, it's a stack overflow, it's any kind of a problem like that. And I'm not even talking about like an attack. I'm just talking about like a bad piece of software that corrupts the memory of the virtual machine. Is it possible that corrupts the TPM that's virtualized, and then you're just basically locked out of your VM forever, and you can never get back into it because this virtual piece of stuff got corrupted?
Sure. So I don't want to monopolize the answer, but let me just quickly speak to that, and Mike will obviously jump in, throw in anything else he wants to add. So the short answer is, look, we all know, right? There's all this unknown things that are just constantly popping up and occurring elsewhere in a system that can always impact us, right? So when we say definitively it'll never happen, we're proven wrong the next day. So I'm not going to say it's not possible, but given what we know about the nature of the technology, how it implements today, I would say it's not only highly unlikely, but it's considered to be improbable. The reason for it, and let's use VMware as a test case, because VMware implements specifically in a slightly different way. Every vendor has slightly different ways in which they implement the thought process. But VMware, we call the idea of encryption taking place within the VM stored in memory as essentially resident snowflakes. That's what they're referred to. You have these encryption bits that are floating around that potentially are liable to become compromised, right, as you were describing. Hey, we have a stack overflow over here. Adobe goes nuts or something crazy like that, totally unrelated. And all of a sudden, everything blows up, and now everything is purple screened or blue screened, and we can't get in. VMware manages this differently. The VM encryption itself, what's going on, is taking place outside. It's running in such a way that the keys and the virtual information that's being encrypted are not contained directly in the VM memory. And as a result, we don't worry about that corruption because they are sandboxed off, isolated, and they're not going to be susceptible to that as a result. So that's usually the model. And as a result, we're not seeing that as being a major risk.
Okay.
At least not right now. I mean, who knows what malware may pop up at some point.
I wasn't even really getting at malware. I think I was getting at more what you're addressing, which was the idea that something just corrupts it rather than it's a targeted attack, because it's very, like you say, you're never going to prevent every possible outcome. But I'm more worried about Adobe, blowing a gasket than I am about targeted malware, because I'll deal with that when it happens.
Yeah, considered to be highly improbable. Let's put it that way.
Okay, I'll take that. It's kind of like catching Ebola. It's probably not that likely, but
Right.
It's going to suck if you do.
So you guys want to see a little bit of how this works?
Yes, absolutely.
Yeah. Okay. So Mike's going to jump in. We're going to share his machine. And he's going to drive for a couple minutes.
I think what Adam and Mike are saying is there's no known attacks against this infrastructure, this particular technology yet. Right. We just had a great conversation with a researcher from the head of research at Onapsis, and people are asking questions about, hey, like, is this table inside of SAP that stores all the user thing, like, what do you do to lock that down, and does SAP do a good job of securing it? He's like, well, before July of this year, I would have told you, as far as I know, yeah. He's like, but in July, we've got like this heinous, unauthenticated, critical vulnerability that we found that basically lets you get access to that table and crack it wide open without prior knowledge of any credentials.
Those are coding flaws rather than theoretical flaws, which exist in the system. And coding flaws you're just going to have to live with. I mean, are fixed, because when coders do bad things, then we all pay. But
and hey, look, there's been a ton of, not a ton, but a good number of vulnerabilities against virtual infrastructure, against virtual machines and escapes of that nature. And I don't, and correct me if I'm wrong, any of our listeners out there or anyone on the panel today, like, I don't think they've posed a significant problem for organizations, because they get fixed, people implement the fixes, and we go on with life. In the cloud, We've got some of the best virtualization and cloud security experts that work for places like Amazon and Google and Microsoft. Then I'm not saying it doesn't happen. When it does, they remediate the issues.
And the level of fiduciary harm that results from a VMware exploit is going to be so severe that
they're going to fix it. Yeah.
VMware has a vested interest in pursuing those things very quickly and or upfront because of the level of fiduciary harm that results from some kind of exploit like that.
Doug loves that term, fiduciary harm.
Well, they all
he works it in every time.
At least a couple of times. They have to drink half a bottle of vodka every time I say it. So the crew next door is deceased at this point.
All right. So Mike's going to show us how this works.
All right, so I got workstation 14 fired up here. And the first thing you're going to do if you want to implement virtual smart cards is you've got to add a virtual TPM to your machine. So that is done through the settings. And if I go to, let's see here, we'll pull up settings. And you can see I've already added one, had this done before the show, but to show you how I did it, you just go into add, and you'll see it's a piece of hardware. Now, in this case, I've already added one, tells me I can't add one more. The key here is that the virtual machine has to be encrypted prior to this. If I go to another machine real quick, and we take a look at the settings, I can go down to my Add Hardware Wizard, and I can see the Trusted Platform module as an option here, but it tells me that I cannot add this until it's encrypted, as well as being set to use the UEFI as its firmware. So that's step number one, is make sure you encrypt the machine. And that's something we're going to talk about in a little bit, because when you go to encrypt that machine, that's when you're going to assign the password that is going to control access to that machine. And once you get the virtual machine encrypted, then you're able to go back into the settings and add the virtual TPM. Doesn't change much on the machine. Once you get that TPM added, you can launch like TPM .msc. If it's going to let me, of course, good old Windows 10 just went through some updates, and now my search isn't actually launching there. Let's see if I can get it from here. TPM. MSC. See if we can launch that up this way. And what you'll see is what Adam was referring to earlier. This is TPM 2.0, and you used to be able to come in with TPM 1.2. You had all the commands that your particular vendor and implementation of that TPM chip had made available to you. You can see those here. You don't see any of that anymore. Once you go to 2.0, it's all managed. Windows manages it automatically, takes ownership. You still have a couple commands here: change owner, clear TPM. I'll show you this more than anything just to show that this is a VM running Windows 10 in VMware Workstation 14, and it has a TPM. So, which then opens up the door for doing things like virtual smart cards or BitLocker, right? When we think about virtual machines, one of the best things we can do to protect them is whole drive encryption. I don't want somebody to be able to walk off with my virtual machine and fire it up somewhere else. BitLocker, to get the full protection from BitLocker, we want that TPM so we can store the keys there. And so now we were able to do things like that. So with this guy, I didn't think you wanted to sit around and watch it encrypt the drive, but in my virtual machine, you can see the I know, right? And let me blow this guy back up for us so we can see that a little better. But you can see my icon there. I've got BitLocker enabled on in this case, on my operating system drive, taking advantage of that TPM or that virtual TPM and able to store the BitLocker keys in there. So we're able to enable BitLocker. That's a good thing. And again, we can start doing the virtual smart cards, which is something I'm seeing more enterprises starting to get interested in. They want to enable smart cards. They want to take advantage of that capability and the security associated with it. But it does require some infrastructure. You've got to have your smart card readers that your users have access to. You've got to have the smart cards themselves. Smart cards being Mike, that physical device or.
Yeah, I just want to back up. So in a non-virtual world, right, I would have a smart card. I would get into work in the morning. I'd have to put that in my system, boot it up, and it would have to read my smart card in order to decrypt my hard drive. Is it essentially the way it works? Okay.
Yep. And you might have a certificate on there that was issued to you by your PKI that allows you to log into your system, or it could be a certificate for remote access or what have you. And then one of the big downsides of smart cards like that, and what you were just talking about, is the card itself, right? We get the multi-factor authentication or multi-factor dealing with, now it's something I know, the PIN that goes with the card and the card itself. But those cards are easy to lose, right? They're very easy to misplace, leave at home. So now we've got to have provisions for that. What do I do if a user comes in?
Quick story on that. We just traveled to Sands Hackfest, and at least 3 times, both during and after the trip, I had a moment of panic because I couldn't find my YubiKey. Just saying. Because when you're in the office, you kind of have your routine. Like, I always keep it clipped to my belt, blah, blah, blah. And then when you go on travel, for example, is when Mike's talking about people losing stuff, like, well, I got to go through TSA. So now I got to put that smart card or whatever somewhere else because I can't have anything in my pockets. If I want to, maybe I want a Freedom Fondle, but I still don't want anything in my pockets. So I got to put that in my bag. Now there's just a whole opportunity for losing it.
It's almost like the sign they used to have on the tube in London that said, beware of pickpockets, that the pickpockets put up. Now you put up a sign that says, where's your YubiKey?
Yeah.
And watch everybody touch themselves.
And so I was worried that I was going to have to make a tweet. Yeah, I'm a security professional, and I lost my 2-factor auth token at a pen testing conference. That would be bad. On the scale of things, that would be pretty bad.
I think you should just put up, I lost my security token during a Freedom Fondle. And, I may license that domain later. Freedomfondle.org.
Sorry, Mike, continue.
That's great. It brings up another point, too. How long before you thought you might have misplaced your YubiKey?
Yeah.
Right? We're talking about users, and they might, when they go to use their card and realize they don't have it, when did they misplace it? How long ago was it? How long has that been out there somewhere with somebody potentially having access to it, trying to use it? Where with a virtual TPM, or a virtual smart card, I should say, if I'm loading that up on their personal computer, they've got a personal investment. That's their device. They use it for other things. They're going to know if somebody has stole their laptop or if somebody has stole their phone quicker, and they can notify administration, say, hey, look, my laptop got stolen. We can now immediately revoke that certificate, make sure that nobody's attempting to use it, things like that. So there's a lot of pluses to going with virtual smart cards. There's a little bit of a downside. It's not portable, right? It is stored in the TPM or the virtual TPM in the hardware. So if I go to another machine, I can't export that virtual smart card. And I can't get it out of there. So I'm going to have another virtual smart card on another laptop. So there's a little bit of a downside there.
If you're blowing out like live desktops, can you do that? I mean, would the key be blown out with it, or if you were doing just like rolling them on the fly kind of things?
I haven't tried that, so I don't want to say that you can. The provisioning that I've done with the virtual smart cards is all done on the image after the.
Okay. Yeah, so it's just like installing virtual hardware, yeah.
It would be an overlay on top, right? It's not part of the base image. You wouldn't do it that way.
Yeah.
Yep.
Traditionally, you wouldn't. It's not what you do. But
now,
the other. Go ahead.
I'm sorry. If I'm an attacker, can I steal the virtual smart card? Like if I break into the system, can I take that virtual smart card and then go to another system and use that to log in? Or is there's assumingly some kind of technology that prevents me from doing that?
Yeah, exactly. The TPM is protected, and you're not going to get access to it. The virtual smart card, it has it has almost all of the same protection that you're going to get from a physical card. Once that certificate gets on that smart card, you can't offload it, right? It's non-exportability, so you can't get the certificate out of the smart card. Same thing with the virtual smart cards. The virtual smart cards support anti-hammering, so you can't sit there and pound away on the pin. Microsoft, or I don't know, with Microsoft's implementation, it can be done a little differently depending on the vendor, but they have, as I drop my earpiece here, their anti-hammering techniques, you start getting a delay, much like I see on the iPhone and devices like that, where if you put the wrong pin in too many times, it says, hey, try back in 2 minutes. Again, all right, try back in 10 minutes. Pretty soon, you're going to have to wait 2 hours before you try again. So they have the entering.
It's not like a piece of software that I can take from a system and put somewhere else. It's somehow tied virtually to that system.
I mean, the thing you worry about is
Go ahead,
you
Adam.
worry about physical proximity access to the box and somebody co-opting the box as opposed to the certificate, right? You want to be one level up above because we're still worried ultimately about somebody being able to get in front of it and use it incorrectly, but they have to take over the box as opposed to co-opting only the software aspect.
If someone's going to steal the machine, they're going to steal the machine. If someone's going to steal my hardware token, they're going to steal my hardware token. It's
Right.
If someone's able to do that, you got bigger problems, in other words.
And once you get back to that physical layer, all bets are off because, I mean, now you can circumvent all kinds of things if you can get into the physical.
Yeah, I think physical access trumps almost all security, right?
At least every time I've ever seen it.
It can be the bane of our existence.
Yeah, pretty much.
Yep. But the other point I just wanted to raise about going to a virtual infrastructure on the smart card side, we were talking about this earlier. You know, and it's not a primary security point, but indirectly I think it is. And people don't often make this connection. I talk about this with my customers and my students a lot. You know, there is the cost factor, right, which Mike brought up and we both talked about, which is you're decreasing the physical capital outlay, right? So capital or operational expenditure around the line items for smart card, initially acquisition, but ultimately maintenance and replacement over time. You know, I deal with military and government clients quite a bit, CAC cards, which I'm sure we're all familiar with generically, right? And, you know, the cost associated with those things is not inconsequential just from the acquisition standpoint, let alone the maintenance around the infrastructure. But I think the thing that impacts security, aside from the obvious, and Mike raised a great point about this, which is potentially the speed at which we could turn around that recognition of loss and reporting, government and military in particular, you know, that's an offense that potentially, you know, especially in these days and times, unfortunately, if that CAC card goes missing, you don't report it within what is considered an operationally reasonable amount of time, you have a lot of explaining to do and may wind up in a very difficult position.
Right.
But more importantly, I think the savings we recoup potentially from that investment and not having to maintain it the same way. My pitch to customers and my thought process with students is how you impact security is by redirecting that investment the company would have made into better awareness, better capabilities, and ultimately benefit the system by broadening and strengthening our defensive perimeters and all the things associated with shoring that up. Then I think you really see an economic benefit being turned into a security benefit that's measurable. Right? We get something valuable out of that. And I think that's what businesses often miss. Hey, we're saving all that money. Let's zero that line item out and let's put it somewhere else. No, let's reinvest it and make sure we spend it to achieve this even better levels of security, but from a different technology perspective. I think that's really where the savings and ultimate benefit comes from.
Yeah, absolutely.
Sorry, Jeff, you're still there with us? We had this conversation when we were at Hackfest. The current technology in the studio is always evolving, and it evolved to the point where we led to this area where I can't see all the Skype guests.
Yeah.
And did you notice that just now?
I did, yeah.
And so Jeff's not up on the screen. We're not able to look at Jeff's reactions and like cut to him for a question. And I've apologized to Jeff for that, and we're going to fix that in the coming weeks so that we are able to see you. But Jeff, I wanted to go to you and see if you have questions at this point for Mike and Adam.
Yeah, I've had like a dozen of them.
Sorry.
It's hard to break in.
Sorry. And you're probably waving your hands, and I couldn't see. That's Jeff's signal to me. When Jeff waves his hands, I know to go to him for a question, but I can't see Jeff. Sorry,
Yeah,
Jeff.
now he's waving.
Yeah.
Well, I stopped waving when he said he couldn't see me.
Yeah.
Well, I was going to go my first question was, what does this thing look like? But then we did a demo. So we kind of have a vision of it. You've already talked about how things ultimately fall or fail. I wanted to highlight some of the things you said, like at some point you talked about it all depends on the implementation. So you've caught most of the comments that are in the sidebar comments I wanted to make throughout the whole thing. I guess my most basic stupid question is, because we were talking about the virtual desktop at the very beginning, VDI, is that what it's called?
Mm-hmm.
VDI.
What does somebody run a VDI on?
Like the
sure.
user.
Oh, actually, it's great. Great question, and we often overlook the obvious, right? In the rush to answer the enormous, bigger ticket items. So VDI, really, the way the technology was positioned and kind of came about, would be an extension of minimal terminals like the WISE terminals, right?
Or
Things
BYOD.
like that. Or BYOD. Yeah. And so VDI can run. Depending on what the customer is doing, what they have laying around, what their end game is. Is it a hotel with VDI instances up at the desk for check-in? Is it a remote, computer or a group of computers that are in the field, right? That may be used in a remote area where we have to do certain things. Probably minimal hardware. We're not talking about very expensive, very high-end systems. We just need something that has enough resources to essentially connect to a network, have storage locally, minimal memory, minimal CPU to be able to run. But it can be a very low-end system. It doesn't need to be anything very complex and high-end.
No, absolutely. An organization can.
Is it in a browser? Like, in certain circumstances, do I need a web browser that goes to the VMware VDI server and then it loads my
What
desktop?
You're thinking about is, so Citrix kind of pioneered this thought process. Okay. What you're describing is what we call Zen Desktop now and Zen App, right?
Yeah, so that's
the idea behind application provision.
And so in the VDI instance, it's not a web browser per se.
No. It's not activated through the web browser in the sense you need the web browser to activate the instance. You're throwing essentially an operating system instance, a desktop, into a piece of hardware, spinning that up and running it. There are web browsers certainly associated with that, but what you're describing more aptly, Paul, is the idea of application provisioning through some sort of web API or gateway that lets you pull down an app and spin that up, through a farm or something like that, right? That kind of model.
That was a Citrix thing. Yeah, okay.
Right, yeah, what they call Zen App or Zen Desktop.
Jeff's raising his hand again.
Well, I was you brought up Citrix because when you were first describing it, I was wondering what's the difference. Isn't this what Citrix essentially is? You're looking to save money by not supplying everybody with a full-blown desktop. And so, and then Doug brought up the whole idea of the clients or the monitors for a mainframe, which is even more basic, I guess, going back.
Right. Like an X terminal.
Bring your own dumb terminal. Yeah.
Like where X terminal came from. I was trying to describe that to the interns. Like they're like, yeah, we know we run X, but we don't understand. I'm like, yeah, because like back in the day, you had an X terminal, and that's why you had an X term. Like
the old terminal just had enough memory and enough processing power to display the image and manage the keyboard, and that was it.
God, we're old.
I know, it's bad.
Back in my day. But exactly what you're describing, in the sense that yes, Citrix is kind of, that they were much like whether you believe and rightly feel today perhaps that the moniker is earned and deserved. VMware is seen as that pioneer in the virtualization space, right? If you go back, and Citrix is really that pioneer in that space, but from the desktop virtual environment, application servicing perspective. A WinFrame, MetaFrame, you go back in time, all these names for that solution, and that's really what they are famous for. What they have done. They went open source, went into the Zen platform, and kind of threw their arms up and said, "Hey, not so much server side. We're going to focus more on the app and the desktop side." And VMware and Microsoft are kind of battling it out there on the server side. Although Oracle does have a enterprise-grade virtualization solution as well, but it's mainly that.
Jeff, final questions before we get to 5 questions.
Final question. Hopefully, it's a thought-provoking question. So, in the history of the internet and technology and networking and all this stuff that we've been doing, some of us for many years, very often technology comes along that, sometimes it's very pioneering and sometimes it's great, and it's often becomes popular because of the perceived potential cost savings. So, in the early days of VM, in the early days of Citrix, all these things were sold because they would save the customer so much money.
Because desktops were expensive, Jeff, right?
They were. I mean, my first desktop that I purchased, in the early 90s was like $4,000.
I was in junior high school.
It was a Pentium 90, which was
I don't want to hear about it.
Which was screaming. It was top of the line.
If you had like Pentium in early 90s, you were richer than I was.
Yeah, big shot.
It cost $4,000.
Yeah.
So, but oftentimes then, as time progresses, we discover the hidden costs, and things aren't as always attractive as they first seem. So, my question is, do you see any potential pitfalls or things, as this technology becomes more pervasive? What are the potential pitfalls? You touched on some perhaps early on, just not planning ahead, but beyond not planning ahead, do you see any kind of pitfalls or problems with the perceived cost savings?
Sure. So great question, because it forces us to step back and really think, which sometimes, as we indicated, right, is the bane of anybody's existence as you're planning. So I think there's probably three that we often talk about or I focus on with customers. One we mentioned already, and you called that, which is lack of foresight to plan to be able to scale, right, over time and to be effective at your investments, as we said, so you don't make them up front and then not realize the benefit of the technology, but rather you spread them out and really get the maximum benefit of that spend as you go over time. So I think that whole area is one. I think number two is the concern that we come to rely on the technology because we think it's a panacea, right? It fixes our problems. And we don't, as a result, work as hard to figure out how to stay ahead of the curve, and we become essentially complacent. What I see in cloud infrastructure, in data center infrastructure, in those environments that I spend a lot of time with customers is, we've virtualized so much that essentially, as a result of doing that, we don't need as much infrastructure knowledge to manage. We need different skills, don't get me wrong, but we don't need those hardware guys. We don't need those hardcore infrastructure guys that we used to keep on staff, we used to maintain, made up the core of our IT, quote unquote, environment and departments. Either we converted them, flipped them into virtualization / cloud people, whatever that may or may not mean, or they've gone the way of the dinosaur and they're gone. And then when something breaks, and our BCDR environment requires us to fail back into environments that are perhaps having to be maintained by people that don't understand them, I think we have a very significant risk that goes undersold in the organization and under-recommended or under-reported and under-identified. So I think atrophy of skills as a result of shift in technology, because we lose sight of those older skills that may still be very valuable, and remapping them in the appropriate way to really scale, I think is number two. And I think number three is this move, which we've seen dramatically with virtualization with regards to enablement of cloud. You can do cloud at a basic level very, very minimally without necessarily having to scale massively. But you really can't do cloud the way we think of it today without virtualization. It's the key enablement technology. And if you don't have it, you can't really be in the cloud and do anything as a service, which is where everything is heading, more or less, right or wrong. And so I think the third area that's of concern as I look out around the landscape from a threat perspective and kind of just long-term, how do we deal with this, is that this headlong rush into the cloud as people are outsourcing risk. And what does that mean for us? Not so much from a technology perspective, because the vendors are dealing with that, right? They're doing the containerization, they're doing all those things, and we're paying them essentially to manage that risk, which is awesome. I think the problem is we're not necessarily fully envisioning and understanding what the enablement of that risk is as it cycles back to us. Again, I'll refer back to one instance with BCDR. If our BCDR, Business Continuity Disaster Recovery Plan, is we're going to fail into the cloud from on-prem versus fail through the cloud, vendor platform across geography, versus fail out of the cloud back into our on-prem. And we have three distinct ways to do that. I think we run the risk of misunderstanding and not necessarily fully testing and appreciating what those concerns are as we virtualize. We just don't really get it in some respects, unfortunately. And I think those are critical areas for me in terms of customer engagement, dealing with customers, and dealing with the training aspects of security awareness around them.
Now, Mike and Adam, and Mike, you've been here. We've had cigars together. I can totally envision a time where you both come here in studio, likely with Doug, probably with Jeff if he's able to make everything, where we're all sitting in the studio together sharing drinks and cigars. That's a reality, right?
Yes.
Absolutely.
Absolutely.
You can't say no to a good scotch and a good cigar.
There you go. I totally got that vibe from you both. So we have to make that happen. I'd love to have you both here in studio.
We even had guitars on Tuesday. Yeah. We had guitars in the studio.
Oh, nice.
Oh, cool.
I had like the entire, speaking of like music and stuff, the entire production staff was in my office, and we're all taking turns with my various headphones and headphone amps, and it was like a dance party, but we could only do like 2 headphones at a time, so it was a great time.
When that conversation started and you said we were all in my office taking turns, my mind went a whole different direction before you got to the headphones thing.
We took our shirts off because that's just part of it. We had headphones on. It was a great experience.
Paul's office mosh pit.
That's right. It was a lot of fun. So I want to ask you both. Now, you got to play 5 questions with Security Weekly. And when there's 2 guests on, it's a lot of fun because we do like an alternating version of the 5 questions with Security Weekly. So I start with one person. I ask them a question. I go to the next person. I ask them the same question. Then I ask that person a different question. I switch to the other person. You guys got it? You ready?
Yep.
It'll make way more sense once we start. So I will start with Mike. And I will ask you the first question, 3 words to describe yourself.
3 words to describe myself?
Yeah, that is correct.
Oh, gosh. Let's see.
Oh, gosh is only 2. You need 3.
Yeah, one more.
3 words.
I don't know.
That is 3.
I can't describe myself. Yeah. Jeez, I don't know how to describe myself. Laid back, casual, relaxed.
Excellent. We'll hyphenate those first 2 for you. Adam, 3 words to describe yourself.
Well, just take one look at me, right? I'm thinking awesomely energetic hippie.
There you go.
You haven't seen the back with the hair. It's all bundled up right now. And I've got hair down in the bottom of my back. So.
Now, Adam, if you were a serial killer, what would be your weapon of choice?
If I was. You're assuming I'm not.
If you were, or maybe you are.
Weapon of choice, a virtual TPM.
I thought he was going to say his hair.
Mike, if you were a serial killer, what would be your weapon of choice?
Oh, I think a machete would be nice.
Mike, if you wrote a book about yourself, what would the title be?
I've actually had this conversation before, and I am 49, and I would have to have a book that said Mike's Guide to Healthy Living.
Yeah. For our listeners, holding up Mountain Dew, not Code Red Mountain Dew, which we talked about earlier this week, but Mountain Dew and cigarettes.
Not bad.
That's yeah.
Yes.
Classic.
Haven't been, knock on wood, haven't been to the doctor in 30 years. So,
something to be said for the medicinal value of Mountain Dew and cigarettes. Adam,
I'm completely embalmed at this point, so I'm good to go.
Adam, if you wrote a book about yourself, what would the title be?
For me, probably how to drink espresso in every country in the world, because I'm a big espresso head. That's my thing.
Yeah,
Adam,
big time. That's the only reason I keep going.
Adam, in the popular game of Ask Grabby Grabby, do you prefer to go first or second?
I always prefer to go second.
Mike, do you prefer to go first or second in the popular game?
I'm not even sure I understand that question.
It's popular in Europe.
We'll go first.
You need more Mountain Dew.
Go first. Mike's answer is first.
Yeah,
Mike,
I'm going first.
Mike, choose 2 celebrities to be your parents.
2 celebrities to be my parent? Let's go with, let's see. Who would be my father? I'll take Clooney as my dad. And I'll take Lucy Liu as my mom.
There you go. Nice combination. Adam, 2 celebrities to be your parents.
I would go with Sean Connery as my father.
Good choice.
And I would go with Sophia Loren. Sophia Loren is my mother.
Wow. Excellent. Well, Mike and Adam, thank you so much for appearing on Security Weekly. You can find Mike and Adam's content on the ITProTV network. I don't know about you, but like my first task for tomorrow is to go check out their content on the network now after sitting with them for an hour and chatting. You guys are awesome. Thank you so much.
Hey, thanks for having us, Paul.
Thank you very much. Always a pleasure.
With that, we're going to take a short break. Come back. Talk about security news. Stay tuned. Don't go anywhere.